Okay, hello everyone, I'm Jimmy. Today I was talking about spatial mismatch in fish and coral reefs following 2016 mass coral bleaching. What is the coral bleaching? First, we can see this is health coral, and its brightness and have a symbiotic algae on it. And second is stress coral. When seawater temperature is rising, or the environment changing, we can see that the symbiotic algae is moving out of the coral. And the third, bleached coral, we can see that the coral is white, and there is no symbiotic algae. If the environment have not improved, and the coral will dead. Introduction. The mass bleaching of Australia's Great Barrier Reef, we also call GBR, in 2016. It caused a lot of many coral dead or bleached, and relationship between the coral and fish. And some coral are well tolerated, but some are vulnerable. It means that some coral can sustain the high seawater temperature, and when the other coral is dead, it may also is still alive. And coral play a key ecosystem role for many reef fishes. It provides shelter and food for fish surrounding the coral. This is our assumption before the experiment. First, host coral mortality will lead to a proportional decrease in the abundance of the coral-dependent reef fishes. And second, fish mortality would be exacerbated by outbreak of cyanobacteria. And the word exacerbate, it means that the condition is get worse and severely. Material and methods. This is the time we study. In January and April and October, total 10 months in 2016. And January, it means that before the bleaching, and April is at the peak of bleaching, and October is after bleaching. And the study site is in Lizard Island, Great Barrier, Australia. The way we use it is to take a photograph of 1 square meter quadrat, like this, length 1 meter and width 1 meter. And we place on the top of reef, and then take picture from 3 different types. First, we take this picture away from 2 to 3 meters, and we can see the fish on the coral. Second, we put on the quadrat on the coral reef and take this photo. And third, we take this photo from the bird eyes in order to see the benthic cover. All transects were conducted on scuba by 2 divers between 9 a.m. and 4 p.m. And new methods of under visual consents, we now use the traditional. And a total of 133 photo quadrants were analyzed. And across the 10 square kilometer river system of Lizard Island and in North Great Barrier. Result. And in this picture, the x-axis is time. This is pre-bleaching and peak bleaching and post-bleaching. And the y-axis is coral cover. And we can see that there is a significant decline in the coral, and especially is Acropora. It is a species of coral. We can see that when the post-bleaching, it almost disappeared. Then the y-axis is fish abundance. We can also see that it has a significant difference and has a decline trend. And third, the y-axis is species richness. And although it has also a decline, but it is not significant. Temporal variation in leaf coral cover and reef fish. In first picture, we can see the coral is colorful and brightness, and has many fish on it. And the second, we can see the coral compared to the previous one. It has more dark, and no complexity. And the third, we can see that the coral almost dead. But interesting, it also has a fish surrounding. Response of 39 reef fish species to mass coral bleaching. We see that these 3 species fish is common seen in coral reef, and it has a significant decline. And interesting is that these 8 species fishes, we see that it has not decreased but increased. Spatial mismatch in fish and Acropora roots. We see that Acropora changes in coral cover. A picture shows that before the bleaching, we can see that it's so brightness. And this picture shows that post the bleaching, we can see that it's more dark than the previous one, but it also has a fish surrounding. And changing in abundance. As the previous assumed, we say that we assume that the Acropora's loose and the fish is also are loose. But we see that the bar have some increase and also decrease. So this is spatial mismatch in fish and Acropora loose. And spatial mismatch in cyanobacteria and fish loose. We can see that in the pig bleaching, the cyanobacteria is outbreak. Then in the pig bleaching, it also has a gain and lose, and the bar has an increase and decrease in fishes. And this is similar in post-bleaching. Also gain and lose, increase and decrease bar. Discussion. We use a series spatial and temporal match photoquadrat. Record changes in coral and fish during bleaching. Coral present the situation we expect due to the increased water temperature leading to a large number of deaths. However, the loss of fish, the death of coral don't show the corresponding relationship. Perspective on the novel sampling methodology. The parent method used to estimate the amount of fish and coral on a large scale, and could not accurately show the change in the relationship between the coral and fish in a small area. Compared with the traditional methods, the method we use is time cover 10 square kilometers and use 1 square meter quadrat. Meters of quadrat can accurately quantify the impact of bleaching on coral reef fish, which also allows us to examine coral fish interaction at a broad scale. Our survey used a photograph, which was only a moment. It's just like snap of common visual survey. And our experiments only last for 10 months, which cannot say very long. And generally, one of our most unexpected findings was the spatial mismatch between the fish and coral reefs, which is very different from what we assumed at the beginning. And the delay effects of habitat degradation. It is possible that the complexity of coral species in each sample area is not the same. so that some relatively high tolerance coral can continue to have many fish species exist. Therefore, there will be situations where coral and fish do not match spatially. Conclusion. We used a new way to investigate corals and fish spatially, although we were invariably spatial mismatch, and the effect of coral reefs on obligate leaf coral dwelling species was surprisingly limited compared to the staggering use of Acropora. And our results over a degree of optimism that fish are far more behaviorally reliant than we may have previously assumed based on correlation at spatial scale. Okay, thanks for listening.
So, what's the using of the blue block using in your experiment? There's a blue block covered the corals.
Repeat his question.
He want to know the blue bar means.
No.
No.
Maybe in your introduction or method.
Introduction.
There's like a box or block. Yeah.
Bars.
Yeah,
Which?
the block. That's a block or
Like this.
yeah.
And can you say that again? Your question.
So what's that?
What is this?
Yes.
It's a quadrat to survey. We put it on the reef, and we see in this space the coral and the fishes abundance. Okay.
And so what? So what's the using of this? So what can it do?
What can it do, ma?
Yes.
Okay. It can quantify this area, and we choose a 133 like this, and we limited this area, and we have a small scale to this area. Okay.
You said that after coral bleaching and some species decrease and some species increase. Why less species increase? Is the end reason?
Repeat.
She want to know why some species after coral bleaching increase and some decrease. This is the condition we see, and it has no more detail. Explain.
Really?
This is my opinion.
Not asking your opinion, asking what the paper said. Didn't they give any explanation for that?
No.
And in your results slide, what is the difference of soft coral and Acropora?
Oh, what? She wants to know. He wants to know what is the difference of coral and Acropora, and she want to. Sorry, Ricky. He want to know. And the Acropora she present is to present the more detail that this species is decreased more significant. Okay.
Is that your question?
What is the difference between soft coral and Acropora?
This is species different. Different species.
Different species of coral.
Yes.
Okay.
compared to the this part is
Next.
no next part is SCUBA.
Repeat your question.
She want to know what is SUVA. It's like scuba diving. People can wear equipment and down to the water to do something.
Why do you choose photograph, not crossing line survey?
Repeat his question.
You want to know why I not choose the crossing ray? Because we use new methods in quadrat. We want to use this method to preciously know the small scale of the coral and the fish abundance in a small scale, not a large scale.
In slide 11, why does the post-bleaching coral look darker than before?
What's your question?
She want to know why the coral is darker than before. Because it loses symbiotic algae, and it also loses its color. So its color is changed.
I don't know the answer. Sorry. So if that's so every time I thought Jimmy made he used a difficult term, then he explained the term, so which is nice, like exacerbate. That term is really difficult. Exacerbate and the quadrat. So he used this, and then he also showed these because this paper itself is rich in images, and he has presented many of these images. That is the advantage of choosing this paper. So that was really nice. And then, however, when it comes to the explanation of the figure, at the beginning it was quite nicely explained, but you did not explain the color coding. And if Acropora seems to be a little bit like the focus of the discussion, I would probably put a photo just next to the figure showing what Acropora is. All right. And then these simple figures are all nice. However, when it comes to not this one. Okay. When it comes to this, you did not, you say, okay, you talk about the 3 species, so we know these are different species of fish. But what's this? What's this? You did not explain. And then, this one's probably not the most confusing one, I think. The more confusing, the more, okay. This one is confusing, okay. So what's the x-axis? What's that?
I'm not really sure.
You have to figure that out. Actually, these figures are quite simple if you know what the authors were doing. But you need to first know what's the x-axis. And do these and these, do they have the same x-axis or different x-axis? You sure? So that means you have not completely understand this figure. So you need to figure that out. Yeah. So this one, and neither did you explain the x-axis, so that started to cause some confusion. And I also wonder why you leave this big space here. You can move this upward, and maybe you have more space, use larger figure and so on. I don't know. If I were you, I would do that. I would try to enlarge my figure and use large font whenever possible. And then the same question applied to this figure as well, right? So, and apparently, especially this figure, contain the key information you want to discuss, because you say, here you see some specific species, their abundance increase after bleaching. So this is actually a key figure of the study. So you really need to figure that out, what this figure is talking about. And then actually I think the authors, they provided some explanation for this mismatch in coral abundance and fish abundance, but this is not discussed in this talk. So I hope that next time you can figure that out and then add that information into your discussion. And then, all right, and the conclusion is compared to many other conclusions, they are relatively specific, but I still hope that you can add some missing information, which is why some fish abundance increase after bleaching next time into your conclusion. Okay, so let's thank Jimmy.